Hello all, Professor Kagan here. I've been gone for a little while. I'm not going to waste your time by explaining why. That'll become clear enough as we continue on here. Over the past 6 months, I've been constructing, modeling, wiring, and modifying, all in the effort to acquire my very own Ghostbusters proton pack and neutrino wand, with some additional goodies and ideas as well. As I walk you through this process, you're going to see a lot of rough work, shoddy craftsmanship, poor wiring jobs, bug snacks, and a lot of feature creep. Despite this, I hope you will also see how I've improved over time, and how much better stuff looks later on. I won't say they look good, but, you know, better. I had purchased a small 3D printer last year, and I mostly used it for my LEGO trains, making wheels and couplings, because LEGO train stuff can be overly expensive. And it wasn't until I had bought a Spirit Halloween proton pack that my quest for good cosplay had started. The pack is scaled down to 80% of the size that the screen-used packs are. Which is okay for me, because I'm a manlet who injured his back 8 years ago. So the less weight to lug around is very nice, and this pack often serves as sort of a starter base for fans anyway. It's not uncommon for people to modify this. The problem became clear when I had found out that the pack only makes generic blaster noises. And I didn't like the neutrino wand. It was way too small and not very detailed. Of course, you must understand that I paid around $70 for the pack. It is, of course, a far cry from the stuff that fans make that go for hundreds, if not thousands of dollars. I decided that I'd build my own neutrino wand that was 1-to-1 in size. I would then modify the Spirit pack to suit my taste, as most people do, as well as adding my own lights and sounds. I started out knowing that I wanted 4 sets of lights that matched the 4 cyclotron light ports on the pack, and a set of lights for the power meter. So I took an Arduino I had handy and wrote some simple code. I assigned each set of lights to a pin, and had them turn on for a set amount of time, and then turn off. I had the Arduino loop through each cyclotron light set, as well as varying the brightness of the lights in the power cell. I had a pin set to output a high 5-volt signal with the intention to connect a switch between that pin and another. This would detect that signal in an if statement, toggling whether or not these lights would function. And this was pretty much half of the computational logic and software writing done. I'd next have to implement a way to play sound effects at the flick of a switch. I'm sorry to say that this took me way too long to figure out, and I had made it way too complicated. I'll elaborate further once we get to the point where I worked out the solution and went with it. Getting there was kind of silly and dumb. Next, I decided to start work on the neutrino wand. I have experience in modeling with Autodesk Inventor and AutoCAD, but I didn't quite trust myself to design my own version of the wand at first. So I began my first big lesson over the course of this project. There's no need to constantly reinvent the wheel. I found a wand on Thingiverse and downloaded all the files included, where I encountered my first problem here. My little 3D printer's build area was about 4 inches by 4 inches by 4 inches. Just barely too small for certain parts. Something about me that you should know is that I try to make do with what I have when I'm trying to accomplish something. And I had to make that work for the time. You'll find that I'll be at odds with this throughout the entire project. But nevertheless, I decided to split the parts into several more small parts so they could be printed and then super glued together. As you've seen from the pictures I've placed through the video, it's not good looking. You know it, I know it. That's why later on I built another better looking wand, but I will also elaborate on that later on. Over time, I printed parts for this first wand while I was in and out of my dorm room with a little 3D printer just whirring away, playing its part and birthing my very scatterbrained project. Once I had a good amount of pieces, I started gluing together the wand, spending way too much money on super glue and giving absolutely no thought toward any electronics or wires that may need to be placed within it. I painted the various pieces too, and placed a couple of lights in the main body of the gun. Any crevices or uneven sections would be filled in with a mounting putty or a model plastic filler. Like I said earlier, when gluing parts together, this didn't look too good either. But at this point, I had done all that I could do at the time in constructing the wand. While I was deciding how to proceed with wand construction, with things like labels, tubing, the barrel, that kind of thing, I decided I'd round out my Ghostbusting arsenal and build a proton grenade from the IDW comic series. Like the wand, I found a model online and proceeded to print it, paint it, and glue it together. It was a very simple build process, and the circuit was even simpler. Just 2 LED lights and a resistor with a little 9-volt battery as the power supply, and a button to activate it. I was quite happy with how this little detour turned out, and was ready to proceed with my wand. I had found some acrylic tubing and silicone aquarium tubing on Amazon, and I also purchased a Neutrona wand decal kit from Movie Sign Company on Etsy. Not sponsored, of course, but I am going to leave links to models I've printed and stuff I've purchased on Etsy in case anybody wants to utilize these resources. Chances are, if you're watching this video, you've probably already used some of these, but oh well. I'll also do the same for the models that I made. More on those later. This is the 3rd time I'm saying that. I know. We'll get to it, I promise. The parts came in, and I fit the tubes and decals to the wand, as well as basic lights and switches to be used later. By this time, I had the majority of the wand complete. However, I wasn't satisfied. The wand didn't, and still doesn't, look nearly as good as I want. I didn't like that so many parts were printed in sections, that so much of the wand was glued together, and that the prints in general came out rather rough in some cases. I wanted it to be more modular. I started thinking about the extended Ghostbusters universe, specifically the video game, in which the Proton Pack and Neutrona wand received numerous upgrades. So I thought it would be pretty cool to represent these upgrades, maybe not on the pack, because that would require a lot more modification that I don't feel comfortable doing. But with the wand, my path was pretty clear. I could build a wand capable of receiving accessories, and you'll see how I do that shortly. From the outset, I wanted this wand to have better materials, like I said, more modularity, less glue. I designed my gun box, the main piece of the wand, and included a small framework inside. This framework had 2 pegs that would allow me to swap Neutrona wand accessories from across the extended universe. I first designed a side plate that would make the wand look like the standard version in the first 2 movies. Then I began designing the various upgrade parts from Ghostbusters the video game. During this time, I had a friend print my new gun box while I was waiting for my new Ender 3 printer to come in the mail, and I purchased some metal pipe to use as the front and rear barrels of the wand. I cleaned up the pipes, I gave them both a coat of black spray paint and then a coat of black acrylic. Once my printer came in, I printed and painted the first side plate for my wand, and it fit perfectly. I'd also fitted the painted pipes. I glued these into place because I don't really intend on replacing them. And then I carried on adding other parts of the wand, allowing me to make this little comparison shot you should see here. Now that the wand had build parity with the first one, I started building the video game accessory. Sadly, I didn't have many photographic references at the time, so slight spoiler warning, the proportions of the slime blower attachment, as well as the other little bits and bobs that go on there, they're a little off. Starting with this main gun box that I've printed in banana yellow. It had taken over a day to print, and I naively included a lot of support with its internal structure. It took me the better part of 2 hours to get it all out. At this point, I ran out of printer filament, and I decided I'd focus my efforts on the proton pack proper until I had purchased more. So, I got some perf board, and I fashioned 5 little light circuits for use in the pack, 4 for the cyclotron, 2 LEDs for each little circuit, and then 1 that consisted of 4 blue LEDs for the power cell. As you can see, I'm quite the professional labeler when it comes to these pieces. As all of this was going on, I also did my best to work on creating a sound effect player. I really did make this overly complicated. I initially went with a DF Robot MP3 module, which I did get to play a sound once, and I never got it to do anything else. I'm not the most experienced programmer, so the accompanying library for the module didn't make sense to my ignorant eyes. I did try my luck with a similar serial MP3 module made by HiLetGo, but I couldn't get any sort of response out of it, just nothing. This is, of course, due to my lack of skill and or knowledge, but in the end, I did find what I was looking for. What really should have been obvious, I should have thought to have looked for this from the beginning. I purchased it from Adafruit. It's a board specifically made for playing sound effects, and it's so simple that even a random idiot with an ego big enough to call himself Professor could use it. It works by plugging it into a PC, and you can label your sound effects by a number corresponding to a pin on the board, from 0 to 9, I think, and defining whether it'll play once or loop once activated via shorting the pin to ground. Let's rewind a little bit. Before I installed this soundboard, I had been given some free filament from a friend, and continued building the Ghostbusters video game accessories for my wand. I modeled the rest of the pieces, printed them, painted them, assembly. I would later purchase a pressure gauge to add to the back of the accessory on the gun box. Once I had it assembled, it was clear, like I said earlier, that the proportions weren't quite right. The gun box was too long, the slime blower nozzle was not thick enough. It's just not quite right. I think I'm gonna keep it, and I'll just I'll say it's my own little original add-on to the Ghostbusters fan canon. You know, it's the Slime Blower Mark III Snub Nose edition. It's smaller and longer. Is it better? I don't know, but there you have it. I do plan to build a more accurate one in the future. I've been scouring the internet for more reference photos. I also printed a base plate for the Arduino to be mounted to inside the proton pack. I glued the mounting in place, and then I screwed the Arduino into the mounting, and I commenced testing in the pack to make sure the electronics worked, the LEDs and the power meter and the Arduino and the power circuitry, that all worked. With that done, I needed a way to control it from the Neutrino one, and I didn't want to simply snake wires through the proton pack tubing and solder them at each end with no easy removal. So I took to Amazon to see what sort of breakout boards they had for sale. I needed something that offered a decent amount of pins, but was cheap, common and had a port that could fit through the proton pack tubing. I settled on RJ45 cables with male and female breakouts, as they suited the aforementioned requirements. 8 pins ensured I could connect all 4 switches on the wand so I could toggle the lights and the 3 sound effects I had chosen. These were sourced from the Ghostbusters video game, and once I had the RJ45 cables fitted into the pack and wand, I recorded a sound test that I'll play here for you. Okay, starting Proton Pack Soundboard Test 1. We will begin with the power-up sequence, as done by this bottom right side switch on the wand. Due to the power settings as of right now, it may be difficult to get a clear sound, but once the lithium-ion batteries are charged and we're not dependent upon the AA battery pack, that shouldn't be a problem. We will now test the loop shooting. Sounds a little bit better there, and it does loop, so I would call that successful. You may notice that small pops come from the speaker. That's from my left hand, keeping the leads from the AA battery pack on the power exit module. We will now test Proton Pack power down. And now we will just totally disconnect power. And that is the power test, ladies and gentlemen. Once this was complete, I had very little left to do. I soldered the final wiring inside the pack, and originally I was going to use my own self-built lithium-ion battery system, but I decided to use a USB battery bank instead. It's more reliable and I don't gotta mess with it. And something else I learned during this project, you've gotta learn to just cut things when you've been working on something for so long and you're just having trouble with it, so I was like, I'll just use a battery bank, it's fine. I then added a couple of cosmetic touches to my pack. I added a proper ion arm, a clippered valve screw top, a more accurate resistor on the ion arm side, and touched up some paint, new plastic ports for the lights to shine through, and a wooden backing for the pack that I purchased from Charlesworth Dynamics. That's also where I got the little acrylic plastic light ports. I also purchased a V-hook attachment for my pack so I could hang my wands on the pack, and I purchased another female RJ45 breakout so both wands could be used with the internal system. Barring little odds and ends, the project is largely done, or I should say that this chapter of the project is done. Here in the future, I haven't decided when I'll start working on it again. I'm going to buy a few more upgrades and cosmetics for my pack. I have started pre-production on a third movie Neutrona wand. By pre-production, I mean I've written down some things I wanted to have. There hasn't been any real physical work done on it yet. This wand will have an all-metal construction, and it will support the peg system for my accessories that I came up with. I want to give this wand its own brain, put all the computing in it so it's not reliant on the proton pack, but I still want to be able to plug it into a pack and any other packs I make and control its internals. I want a lot of mixing and matching for my cosplay pieces, because I think that would just be really cool. the separate little Arduino brain that I'll put in the third internal one, like I said, it'll be interfacing with future packs, but I also want to give electronics and features to accessories I make. Like for example, it's possible for me to put a small pump and tank in a slime blower and shoot out water that I've colored green with food coloring. And I'd want to have that managed by the Neutrona Wands onboard computer. And there's no telling what else I could do along with all the other accessories, like from the upcoming Spirits Unleashed game. I've also been tossing around the idea of a real Ghostbusters Neutrona Wand. We'll just have to see about that one. If you made it this far, I do want to thank you for watching. I know this stuff isn't the prettiest or the most professional looking stuff in the world, but this has been a long time coming for me. It's the first time in my life that I've been able to dedicate so much money, time, and materials to a project. The fact that I can bring them to life is a dream I've had since childhood. Running around with a proton pack made out of a shoebox and a coffee can. Now I've got something much closer to what my heroes on the big screen used. Thank you all again. Links to models and things used in the project will be in the description. I'm Professor Kagan, Professor Indigo Only.